Hi, my name is Hatem Zain. I'm the founder and CEO of Ossia, based in Redmond, Washington. How many of you would like to have your phone charge automatically without taking them out of your pocket or bag? We need wireless power. For me, wireless means remote, automatic, effortless. But how do you safely and efficiently power multiple devices, and only those devices, at a distance? How do you find and follow the device behind walls and around corners? And can you get all that FCC approved? It is my distinct pleasure to introduce you to Kota, a wireless power technology that addresses these challenges and more. For 6 years, we have been working in stealth, developing and patenting this amazing technology, currently in final stages of FCC certification. And Kota was debuted here on the stage of Disrupt. Kota technology is made up of a charger and multiple wireless power receivers. The charger would be the size of this box, and the receiver would be small enough to fit inside a smartphone or even a AAA battery. Kota is the only wireless power technology that can deliver 1 watt of power at a 30-foot distance, spanning an entire home, powering multiple devices safely. Kota is inherently safe as your Wi-Fi hub. A Kota-enabled receiver device would send out regularly a beacon signal that travels the environment and finds paths to the charger, which in turn returns the power signal only through the open paths between it and the receiver, powering it and avoiding people or anything that absorbs its energy. Thank you. Kota works without line of sight, powering devices behind walls and around corners without interfering with electronic equipment. Like some of the greatest inventions of our time, Kota was discovered by accident. While experimenting with wireless signal management, I discovered you could focus the signal to safely power the receiving device itself. What you are about to see here today has been seen by a select few before Disrupt. We hope you remember this moment. Camera, please. For today's demo, we will use this prototype Kota charger. It's larger than the target consumer version, but that's basically just because of the electronics inside it. This one has about 200 antennas inside it. The current designs we have in the lab reach 3,000 transmitters, and our consumer version has 20,000 transmitters within it. The more transmitters, the higher the efficiency. So I have with me here in my hand a Kota wireless prototype receiver. Basically, this receiver guides the power from the charger to its location and only its location, and uses the power to power devices plugged into it. The demo gods are not working with us today.
All right.
So this light is powered by the charger at this distance. Now, the power is only sent to this location, and for demonstration purposes, we made intentionally this system to slow down and show us what exactly happens when you move away. Is the power everywhere? Am I sending power in all directions? So if I move it away, you can see the light goes off. Now the charger detects that this has moved in this location and refocuses the signal, sending the power back to the receiver, and the light comes back on again. The final consumer system would do this 100 times a second, so you couldn't actually move the device out of the power and having continuous power delivered to your receiver. So the question is, can you charge a phone? We all want that, right? So Kota delivers about 1 watt of power, which is a third of the power of a USB socket, anywhere within a 30-foot radius. And this phone is charging wirelessly. Thank you. So slides, please. We have 4 core patents have been issued by the US Patent Office, and many patents issued internationally. Since Kota can charge a cell phone remotely, it can power multiple devices in a home. Remote controls, console game handles, Bluetooth headsets, wireless keyboards, flashlights, and digital cameras, just to name a few. Just think, this could forever eliminate that annoying chirp from the mystery smoke detector with a dying battery at 3 in the morning. We anticipate that Kota will come to the market in several forms, built into devices and phones, built into standard batteries, and as dongles for current devices so we don't have to purchase new devices to use it. Kota should be available in the market by 2015 to the consumer. And we're currently in negotiations with electronics manufacturers to make this happen. In the meantime, we're working with other markets, such as the oil and gas industry, which has forever sought wireless power to eliminate the risk of disastrous sparking from the multitude of wires powering their sensors. Just imagine the impact of Kota on medical, retail, and the hundreds of devices that make up the Internet of Things. The possibilities are endless. We want to partner with electronics manufacturers to use our components, design, and technology to enable their products to be used to their maximum potential. And we're seeking more capital to build the consumer technology and enable new markets for this game-changing innovation. We want to unleash the imagination of anyone designing products that use power. Join us, and together we can make a world that's always on, always ready. Thank you.
All right. Great job. Cota. Anyone want to jump in? Any electrical engineers on here? Oh, okay.
Well, I mean,
anyone who understands how this works?
a little bit, but
Chris.
this is one of those. So congratulations if you've this is a huge opportunity if you've solved this technical problem. It's some problem that, as I understand, it's been worked on for a long time, for maybe decades, and no one has figured it out. I wonder if maybe you could just at a very high level explain kind of the reasons those have failed and some of the things you figured out that makes.
Yeah, sure. This technology has probably started with 100 years ago with Nikola Tesla, who invented a kind of DC current where he was broadcasting power in all directions and whoever captures it. This is not a broadcasting system. This is a one-to-one high-frequency system. This system couldn't have been possible 20 years ago because we're using frequencies and control circuitry that wasn't available 20 years ago. So you can think of it that the technology is now possible. The need is possible. We have so many devices. And the invention of the method came together. All three things came together. And this is the right time for this technology to come in. Many people have tried to invent wireless power directly by saying, OK, how can I invent, tell your engineers, go invent wireless power for me. And it's like having a big desert, right? And saying, find water for me. So what happens, a prospector would go and drive around and say, you can't find water in the desert. But if you could go on the radio and say, anyone who knows where there's water in the desert, I'll pay them $10,000. And they will say, oh, I live next to one, come to me. What happened here is that I discovered this technique first. And I was thinking, OK, what does this mean? So the signal-to-noise ratio is about 100 million times or 1 billion times. And that means that instead of sending picowatts, you can send watts. Wireless power. So it's like the person looking under the light for his keys, and another guy kicking the keys in the dark by mistake. Here's the keys. And that's what happened.
Can I add to that? Because you didn't actually answer the question, and it might be because it's too complicated for the stage, but the company that we've invested in has gone, and they're way before products, so, and I don't fully understand this, but they've decided ultrasound is the way to go, and they argue that RF stuff is inherently unsafe because it's effectively microwaves and will actually cook people. And it might be dramatic, making it more dramatic than it is, but I would imagine a lot of the technology you developed is around safety to get government authorization for this, or can you actually answer how it's safer? And
sure.
Yeah, okay.
Sure. Our technology is based on Wi-Fi frequency. So if you're trying to broadcast power across distances in a normal sense, you'd need enormous amount of power, and it would make it unsafe to be used in the consumer environment. What we've done here is be able to use a big fraction of the energy that's emitted to be delivered. So you can think if 1 watt is received, we're only emitting a few watts here. And a few watts is very normal. Your TV is emitting a few watts, your fridge, the lights in the ceiling. We're now bombarded by a few watts at a distance, because the watts are not on us, they're far away. The other thing is that this technology inherently avoids people, inherently avoids anything that absorbs this energy. Because the way the efficiency works is that it avoids losing the energy anywhere. And that's what we've done. We created a technology that avoids the loss, and that made it inherently safe, because loss and absorption is the same thing, right?
So are you using multi-antenna beamforming, essentially?
So we don't use beamforming as a technique, because that would be line of sight. So we actually deliver power using reflections of the environment. We do multipath solutions to any kind of power delivery. So,
what do you envision selling this for?
So our target that this would go eventually to the consumer, the price of a Wi-Fi hub. It's not full of electronics. It just has to be big to operate properly.
And is there a way to turn this from a consumer at home application to a consumer walking around the world? Because like when I'm at home, the pain of charging my device isn't that severe. But when I go out at night, like I have to regulate my social life by when my phone's going to die, because I can't call Uber if it dies. So if you could solve that, that's a massive transformation of how humans interact.
Rich people problems.
First world VC problems.
Absolutely. So the problem with charging phones, although we love charging phones, that's not the whole solution. We do everything. But the problem with charging phones is that first you have to remember to charge the phone. And then when you do remember, you have to give it up to some sort of charger, whether it's wired or pad or something. And what we've done here is that we've solved both these problems. It charges automatically in your pocket. It's non-line of sight everywhere. And then we've done that you don't have to give it up, so it's with you all the time. We're talking to, let's say, coffee houses that would love to have this in the stores. And we want to do that next year, because before that comes up, they're willing to put a bigger device in the ceiling somewhere that powers all the customers' phones. We can have dongles and so on. So there is a lot of solutions around that for airports, coffee shops, restaurants, and so on. So.
If you have one of these around the house, will it also keep like your food warm and stuff like that?
We don't have that much power to keep your food warm, even if we wanted to.
There are people who have talked about this who are invested in you failing because they're your competitors, who said this is impossible to keep this safe. And, okay. I believe that they don't know enough to know why this is safe, but I just can't get around. I don't understand yet how it's
Agreed.
safe.
It's a good thing you're sitting next to.
Safety.
Yeah, this is the perfect seating arrangement here. We have
right. Yeah.
I'm so happy to be over here right now.
Yeah. Okay. Here. Safety is our main concern for our technology. I said we took 6 years to build this technology, and some of the reason for that is that we couldn't find investors who would believe it would work. We couldn't find investors who thought it would be safe enough. We couldn't find investors who thought we could make it small enough. We couldn't find investors who thought we can make it cheap enough. But as we worked through these years, we were able to solve and prove these things. Now, the safety, I knew it was safe But as I analyzed it more and more, I discovered it was inherently safe. You just couldn't make it unsafe. You couldn't make it unsafe. You'd have to, I don't know, switch it off. I don't know, it could fall on you or something. I don't know, you can't make it unsafe. This is a technology that is inherently safe. The physics of it works like that. I'm a physicist myself, and I've been working on this for a long time. This is 2002 when I came up with the concept. I've been analyzing it, doing simulations and so on, and I got some PhDs working with me, got university professors who analyzed it and wrote papers on this for the company. And that's how we got here. Once we got over these hurdles, we were able to raise more and more funds. We've raised over $3.5 million in the last 6 years to build this. We have a 15 engineers team.
Is anyone up here an investor, since you're secretive about that?
No one is invested from this.
So do you need that form factor, by the way, to get a 30-foot radius?
Yes.
Or to get the power?
Both. That gives you 30-foot radius and the power, because we're able to integrate the technology to reach 20,000 transmitters within that.
But if you thought about the reason I asked the question, I just wonder whether there's a different minimal viable product to get going.
Yes.
Whether there's a smaller form factor that maybe has 3-foot range or 10-foot range. It just eases your market.
Funny you should ask. So we're having car manufacturers interested in this technology, because it could fit inside your car, powering all the devices without the kids in the back playing with iPads and iPods and so on. So everybody gets charged in the car. That's also safe. And the beauty of the car being a metal shell makes the range really strong without having to have a really massive array inside it. So,
what's the inefficiency? So for every piece of for every watt of electricity that goes into the device, how much actually gets delivered? What's the loss?
Absolutely, great question. So let's look at the regular phone charger. So I charge my phone at home. So I have a charger in the office and a charger at home. So at home, I charge it in. And when it's charging wired, you're getting 50% efficiency. Then I unplug the phone and I go to the office, use it for a few hours, and then I plug it back in at the office, and then same way back. 50% efficiency during charge and 0% efficiency when you're not. I'm consuming power in two places. The efficiency of my phone chargers during this period, the 24 hours, is about 9%. We do about 15% efficiency. Overall, we reduce power consumption, but also, because we replace AA batteries and so on in your home, these batteries, which cost whatever, a few cents or half a dollar each, get thrown away. They have to make each battery, they use 2,000 times the energy of the battery to make it. So every time you're throwing one, you're throwing 2,000 charges. We want to stop that hemorrhage. We want to ensure that the power stays in your home, you're using it. So 15% efficiency is far better than 1 per 2,000.
But if this were sitting in a coffee shop, how long would it take to charge an iPhone?
So let's take this to the future. What does this lead to? Now, I did say that it's about 1/3 of a USB socket, which ends up that if your phone charges in 1 hour, it's going to take 3 hours to charge. But if you have a charger in your home, in your car, at the coffee shop, at the restaurant, and at work, and so on, you're charging all the time. So you wouldn't worry about how long it's going to take, because first, your phone is with you, you didn't give it up.
So you want it to be ubiquitous, and then you can stop thinking about it, and you can just constantly charge.
It has to be, because batteries are constantly the pain point for us. And ask the companies in Silicon Valley. All the gaming companies that here and everywhere are like, we want our consumers to be able to have more power to keep playing and using our technology. Cell phone carriers would love this technology because it allows their customers to use their phones even more.
So we're unfortunately out of time, but you guys did a great job. That's Kota. Thank you guys very much.
Thank you.